Space is difficult because space is not really very friendly. You give challenging jobs to engineers, and when you challenge them, you get incredible inventions.
I think we will find signs of life elsewhere. This is the question of design meeting certain functions.
Parachute has deployed and we are seeing significant deceleration.
You can't get it right the first time. No matter how smart you are, you cannot imagine everything that's going to happen.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
In the vast expanse of the cosmos, where science meets the unknown, there's a force that propels humanity's exploration towards the cosmic future we've imagined in films. That hidden force is design and engineering. Astronomers of the Renaissance taught us how to think about the universe. But space exploration only began with the first satellite launch of Sputnik in 1957. There have been many pioneering manned and discovery missions, the International Space Station, and more recently the James Webb Telescope. All of these programs were launched by national space agencies. But today, not only governments compete to go to space, there's a new player. Companies like SpaceX have entered the space race and space is being commercialized. Investment in the industry is skyrocketing. In 2021, $16 billion were invested in startup space companies. As technology is becoming cheaper, many say that private investment has set off the second space age. But exploring space is a challenge.
Not because they are easy, but because they are hard.
We went to a place where it all started. Pasadena, California is home to the Jet Propulsion Laboratory and NASA Center that plans robotic missions to explore the solar system.
Space is difficult because space is not really very friendly. There's no atmosphere, there's a vacuum. If you stand on a comet and you're in a full sunlight, you're maybe at 130 degrees C. You step over to the shaded area and you're minus 130. Right, so these are the kind of environments that you have to deal with.
Temperature extremes and the vacuum of space pose a big problem for scientists and engineers. Mistakes in the design of spacecrafts and other space technologies have led to disasters. But as challenging and unreachable as space may seem, it doesn't stop us from venturing into the universe.
The design is definitely driven by the need to meet certain engineering requirements. This is the question of design meeting certain functions.
You could consider Dr. John Mather a kind of time traveller.
The Academy of Sciences has decided to award the Nobel-prize in physics jointly to John Mather and George Smoot.
In 2006, he received the Nobel-prize in physics for his work on cosmic background radiation, which proved that the beginning of the universe as we know it started with the Big Bang. For the last 20 years, he's led the NASA science team building the James Webb Telescope, the most powerful telescope ever constructed and a real-life time machine. It allows scientists to observe Mother's prime fascination, the light coming to us from the very beginning of the universe.
Astronomers use telescopes to see out in space and back in time. Based on the fact that light travels at a certain speed, you are looking back in time when you look at things far away. So Hubble telescope was launched in 1990, and it immediately showed us, as soon as we got it fixed, that we couldn't see all the way back to the very first galaxies growing from the Big Bang. Because we need to see farther back in time, and the expanding universe stretches out the original visible light until it's infrared when we get it. So please build us this other telescope, bigger and more powerful and doing infrared light. The technical implication is a telescope which is so large that it will not fit in the rocket without being folded up. It implies the telescope must be cold, so it does not emit its own infrared light. And in order to get it cold, the only place we can put it is far away from Earth. The Webb telescope is naked almost. It's got a one-sided umbrella, which protects it from the heat of the sun, the Earth, and the moon. And the rest of the telescope is radiating its heat away to outer space, so it can get cold all by itself. That's why we have this special requirement to be out in space with a cold, very large infrared telescope.
25 years ago, it was when we built the first sun shield for James Webb. And that was 25 years ago when we deployed it. We built it half scale. We pumped it up. We had struts that were made out of aluminum, and we pumped up aluminum. It kind of looked like one long giant Coca-Cola can, silver, so Diet Coke, I guess. And it had foils that were reflecting light. And I'm telling you, when this sun shield was unfolding, about a year ago, I was looking at this. I knew all the issues and problems with foils, with rips, with uncontrolled deployments. I was terrified, but it all worked perfectly.
Have the recent design breakthroughs brought us to the cusp of a new space age? How close are we to establishing human presence on other planets? And what else are we going to find in the vastness of space?
We certainly have the ability to go to the moon and build a habitation there and learn what it would take to go even farther off to Mars.
I'm working on the next helicopter for Mars. That's very exciting. The current helicopter, there's a little toy helicopter that's flying on Mars right now. It's called Ingenuity, but it's just a technological test. This one will be much bigger, will be almost the size of a car, and it will do a lot of science investigations.
I think we will find signs of life elsewhere. So if my gut feel is correct, then we should find it everywhere that there's water.
I also worked on spacecraft Cassini. That one went to Saturn and also made some amazing discoveries, like the fact that the moon Titan has two oceans, one on the surface and one underneath. One is made out of water, the other one is made out of methane and ethane. So that was very exciting, and that's where another probe will be flying in a few years to see if there's any potential for life on Titan. Very interesting place.
We're very excited about looking for those little planets that might be like Earth. As you know, almost every star has a bunch of planets, and some of them are about the right size to be sort of like Earth, the right temperature to be sort of like Earth. So American astronomers declared that that's their top priority for the next great observatory. See little Earth-like planets around stars like the Sun, and see do they have oxygen and water and other things that might be signs of life. There's a lot of surprise coming in astronomy very soon.